Moving on to J27, which is all about rational exponents. This is our last section in Unit 0, so that means your first test is coming up. And what this section is talking about is how to translate a expression from radical notation to a notation that involves rational or fraction exponents. Okay, so let's go ahead and look at this. When we have it in radical form, right, we have our little root number here, and we have whatever our radicand is, and it may be raised to a power, right, or it may be to the first power. But this is how we're used to seeing it, right? What we're going to look at today is getting used to the radicand being written as a fraction exponent where we represent the power over the root as a fraction in the exponent position. Okay, so with rational exponents, just going kind of between the two, we want to look at these. So if I have a to the 1 over n, remember the top number is your power, the bottom number is your root. So this is a to the first power, and we're taking the nth root of it. So we can write it as the nth root of a to the first power, right? And then the first power we don't have to write. So if we have a power other than the first power, a to the m power over the nth root, we would write that as the nth root of a and then raise it to the m power. Or we could actually do the power first. We can do a to the m power and then take the nth root of it. Okay. And then this is the same type of thing, except if our exponent is negative, remember we have to move it across the fraction line. So here we would have to move it down to the denominator, and then we can put it, and then it's in the form that we need it in, right? So the biggest thing to remember is which number represents the power and which one represents the root. Okay, so if you think about your powers up here, like where your muscles are, right? And roots grow like in the ground. So think of this as your power. So let's think of like a little man with like big muscles. Okay, power, muscles. So there's our, well, that's not a very good dude, whatever. Not an art class, right? So think of like your power and then roots that like, you know, grow in the ground. Okay. So power over root. Power over root. All right. So let's look at some examples. So the first set of examples are asking us to convert what is given to us to radical notation, meaning we want to end up with some type of radical symbol. Okay, now I put a square root here just to like represent a radical. Doesn't necessarily mean it's going to be a square root. Okay, it's going to be, you know, whatever the nth root, whatever we're dealing with, whatever the root is of our problem. Okay, and then once we get it in radical notation, we're going to simplify it if that's possible. Okay, so remember that little fraction exponent represents power over root. So this is 7 to the third power, and then we're taking the fourth root of it. Okay, so this is 7 to the third power, right? The power over root, and then we're taking the fourth root of it. Okay, now if I want to simplify this, this means that my index number is 4. I need 4 copies of a number. And notice here, I only have 3. I have 7 to the third power. So I don't have enough 7s to be able to simplify this radical. So if I can't simplify it, then I'm just going to go ahead and multiply it out. Okay, so this gives me the fourth root of 7 to the third power, which is 343. Okay, all right, let's look at the next one. So the next one, I have a negative exponent. So before I can convert it into radical form, I have to first get rid of that negative exponent. And I do that by moving it down, or flipping it, right, into the denominator. So this gives me 1 over 8 to now the positive 5/3 power. Okay, remember the top is my power, the bottom is my root. So if I want to rewrite this in radical form, I have 1 over, I'm doing 8 to the 5th power, and then I'm taking the cubed root of it. 8 to the 5th power, right? And then I'm doing the cubed root of it, okay? The other way that I could do this, because we have this rule, let me just scoot back up here. We have this rule that actually says we can do the power first. This is how I have ours written, right? We can do the power first and then apply the root, or we could actually do the root and then apply the power. You should get the same answer no matter what, but actually looking at this one, I think it might be easier to do the root first, right? Because 8 is a perfect cube. So I'm going to simplify the 8 first and then apply the 5. So I'm just going to rewrite this. 1 over, I want to do the cube root of 8 first because I know what that is, and then I'll apply the 5th exponent, okay? So the cube root of 8 is 2, right? And if you need to, you could prime factor this down and you'll end up with 3 2's. Okay, so the cube root of 8 is 2, and now I apply that 5th power. 2 to the 5th power is 32. So I end up with 1 over 32. Okay, so far so good? All right, let's look at going the opposite direction. So instead of starting with a fraction exponent and putting it into radical form, we're going to start with a radical exponent and put it into fraction form. Okay, so this one, notice this is my power, right? And this is my root. So all I need to do is write my radicand, which is everything under the radical, okay? If there's more than one thing, we want to make sure we use parentheses. So I'm going to go ahead and keep my 7xy in parentheses because that's my whole radicand, right? And then I'm going to raise it to my power over my root. So my power is 5 and my root is 4. Okay, and that's all we have to do. Okay, that's all we have to do. We're just going to leave it like that. Okay, same thing with this one. I have x to the 3rd power and I'm taking the 6th root of it. So this is my root, this is my power. I'm using an x to represent the radicand, right? And then I do power over root. So my power is 3 over my root, which is 6. So that little fraction's up in the exponent, right? And then on this one I can actually simplify because that fraction is reducible. So we're going to go ahead and write this as x to the 1/2 power. And then I just leave it like that because they wanted our answer in exponential notation. Okay. All right, let me show you one more problem type and then I'll have y'all try some. Okay. So let's look at the examples at the top of page 40. It says simplify and then, if appropriate, write radical notation. Okay, so not always going to be appropriate, but if appropriate, we want to go ahead and leave our solution in radical notation. Okay, so we're not in radical notation yet, so let's go ahead and simplify this. Remember, when we're multiplying, this is good old exponent rules, right? We're multiplying the same base, we can combine the exponents. So here we're multiplying, that means we can add the exponents. So this is the same thing as x to the 5/6 plus 2/3, right? Now in order to add those, either we're going to use a scientific calculator that can do fractions, or we're going to have to get a common denominator. I'm going to go ahead and just get a common denominator, which it would be 6, right? And this one already has a denominator of 6. In order to make this one's denominator a 6, I have to build it up a little bit. So I'm going to multiply on top and bottom here by 2. So that way that fraction has a denominator of 6. Okay? So that gives me x to the 5/6 plus 4/6, right? When I rewrite this one. And now I can combine them. So that gives me x to the 9/6. And x to the 9/6 is actually a reducible fraction, right? I'm going to go ahead and write this as x to the, if I reduce 9 and 6 both by 3, I end up with 3/2. Okay? So power over root. This is my power. This is my root. So I'm taking x cubed and I'm taking the square root of it, right? So I'm going to go ahead and say this is the square root of x cubed, right? Or in other words, this is the square root of x times x times x, right? To simplify a square root, I have to have 2 copies of a base. So here, since I have 2 copies of an x, that means I can take an x out, and I'll be left with that additional copy. Okay. So here's the x that I brought out, and then the x that's left over under my square root. And I leave it like that. Okay. Let's look at another one. So again, we want to combine into one exponential expression and then put it into radical notation if I can. All right. So here, same thing, exponent rules. X plus 3 is still just a base. So we have a base to a power and that same base to a power. And we multiply bases that are the same, we can combine the exponents. So this means we have x plus 3 raised to the 5/2 minus 1/2, right? And then I just do that subtraction. So this gives me x plus 3 raised to the 4/2, right, when I subtract my fractions. And then 4/2 is actually something that simplifies, right? This is the same thing as x plus 3 squared. Okay. And I don't think it has you multiply it out. I think because we're dealing with exponential notation, we just leave it like this. Okay. All right. So there are several for y'all to try. Go ahead and pause the video, and once you've done them, or if you get stuck, go ahead and unpause and we'll go over them. All right, let's go ahead and look at number 1. Number 1, we're converting to radical notation and then simplifying it if we can. Okay, so here our power is 3 and our root is 4. So we can do 16 cubed and then take the 4th root of it, or we can do the 4th root of 16 and then whatever that equals, then cube it. Okay, either way you do this problem, you're going to get the same answer. Okay, I'm choosing to do this one because if it's possible to simplify the 16 before cubing it, I get to deal with a lot smaller numbers. Okay, so this is the one I'm going to do. So 16 is the same as 4 times 4, and then each of the 4's break down to 2 times 2. Since it's a 4th root, I need 4 copies of that 2 to be able to bring it out. And that's exactly how many copies I have. So because I have 4 2's, I can bring that 2 out. And notice I don't have any other factors here, right? So that means the whole thing simplified to just 2. So this middle piece became 2, and now I just need to apply that exponent of 3. So 2 cubed gives me 8, right? Second one, same idea. First, I have to get rid of the negative exponent. So I'm going to move the negative exponent and its base down to the bottom. So I have 1 over 32 to the 4/5. 4 is my power. 5 is my root. So again, I could do 32 to the 4th power, which would be a huge number, right? And then figure out what the 5th root of it is. Or I can do the 5th root of 32 first, and then apply it to the 4th power, right? Whoops, which I did not do. Let me fix that right up. All right, so we're going to do the 5th root of 32, which if we prime factor 32, we'll see that we actually have 5 copies of a 2, which means that the 5th root of 32 is just 2. So the 5th root of 32 becomes 2, and then we're going to raise it to that 4th power, okay? And then 2 to the 4th power is 16. So we end up with 1 over 16. All right. All right, let's look at number 2. Number 2, we're starting out with radical notation, and we're moving it into exponential notation, not rotation. All right, so here our power is 4, our root is 12. So we write it as x to the 4/12, which then reduces to x to the 1/3. Okay. Same thing on B. Notice here there's no little index number written there. So when there's no index on a radical, it's an implied 2 because it's an implied square root. Okay. So I went ahead and wrote it with the 2 in there. So my power is 5, my root is 2. So we can write this as x to the 5/2. Okay. All right. And then we have a couple more on the next page. So on the next page, we want to go ahead and simplify these, and then if possible, stick it into radical notation, okay? So on the first one, we have x to the 1/2 times x to the 2/3. Since they have the same base, we can combine the exponents. In order to combine the exponents, we need to write them with a common denominator. Once I have a common denominator on those exponents, I can combine them and write it in radical notation. So here my power is 7, my root is 6. So I'm going to do the 6th root of x to the 7th power. If I have 7 x's, that means I have one set of 6, right? If it's a 6th root, I need 6 copies to bring out an x. So I can bring out one x, but then I have this other x that's left over. So it stays under my 6th root, okay? All right, let's look at one more. This is old school exponent rules, right? If we have a base with a power raised to a power, we multiply exponents. So here we need to distribute that 2/3 exponent to each of the base's exponents. So that means I'm going to do m to the 1/2 times the 2/3 exponent and n to the 5/2 times the 2/3 exponent. So I went ahead and just wrote that out here. Okay. When I multiply the exponents, I get 2/6 and 10/6. And then both of those actually reduce, right? So this one reduces to 1/3 and my n's exponent reduces to 5/3. So notice what we have here is the powers are on top, right? And the roots are on bottom. So both of these have a cube root. So I'm going to write them together under the same cubed root, and I'll have m to the 1st power, because that's the number on top of my fraction exponent, and n to the 5th power, because that's the number on the top of its fraction exponent. Okay, so m to the 1st power is not going to simplify, right, under a cubed root. Cube root means I need 3 copies. M to the 1st power means I only have 1, so I can't do anything with that. But n to the 5th power means I have 5 copies of an n. So if I have 5 copies of an n, then I have at least one set of 3, right? So for the first 3 n's, that means I can take out an n, and then notice I'm left with 2 n's left over. So I write the n that I took out, outside of the radical, and then inside the radical, I have my m that wasn't going to simplify, and then I have my 2 leftover n's that were left over, okay? All right, so that is the end of J27. So you should now be able to complete that homework assignment, which concludes Unit 0. So be sure to watch the little short video on how to review for the Unit 0 test, and good luck on it.